Thank you very much. Not torturing you. The torture only begins now. But maybe there are still some people in the back. I see some free seats here. Maybe if you have a free seat next to you, you could raise your hand. Like, okay. Oh, it's only 2 seats. So there's one here in the first line, and then there. So the 2. Yeah. So I don't know if people still do that. There used to be this thing called Twitter, and people used to tweet on it during talks and then send some screenshots. That doesn't exist anymore, and I'm not on X. But if you wanted, you can tag me on Blue Sky or Mastodon. Just saying. And I don't know if, I guess that's the hashtag for the conference. I don't know if it's like official or something. Maybe not. Just use it. Doesn't matter. For a fascinating programming language. I pondered different titles for the talk. I think at the end, now I left it because it was in the program, but I also saw an article that I found very fitting that was called Programming Languages Nerds Get Excited By, right? Because we're all, right? We might be programming language nerds, and some languages are just kind of exciting. And also you've probably never heard of, okay, there's so many of you now, so maybe it's 4 languages, maybe 1 or 2 people have heard of, I don't know. You might know the language better than me actually, then please speak up. Also you can interrupt me anytime. This is not a YouTube video, well, unless you're watching on YouTube, I'm sorry then, but for the people that are here, this is not a video, I'm real. We can talk, and I'm going to start the time now. That's already too late, but yeah, 4 languages in 40 minutes. We'll see. Yeah, obviously that's not going to work, right? I cannot like teach 4 languages in 40 minutes. So, okay, first revelation. It's not really deeply about the languages. It's about concepts in languages, right? Like some languages are built around a big idea, or I made them build about that. Like maybe they have other things, but I identified one big idea that I found fascinating about the language. So I'm really not talking about, I am mostly talking about 4 concepts that I hope interest you. One is effect systems, right? We all think there's going to be another talk on effects in Scala later today, which is probably going to be interesting. I haven't seen it, but effects, I think, are the next big thing in programming languages. They're now getting more mainstream, so we're going to talk about effect systems, content-addressed code, right? Very interesting concept, very mind-blowing. Some of the things, at least to me, that I talk about are a bit mind-blowing. You might leave this a bit confused, right? I can only give pointers. I want to stimulate your interest. If you get really into these topics, then you're going to have to do your own research afterwards anyway. Concurrent logic programming, that's the reason I do this talk. I have like an old law of a language that totally fascinates me. We're going to talk about that. And then failable expressions, the language, okay, I'm going to reveal the languages now. Big moment. These are the 4 languages I want to talk about. Flix, Unison, Strand, and Verse. Who knows all of these, has used them? Or who knows one of these and has, okay, that's a lot. Which ones? Unison? Who has used Unison? Okay, and who has used Verse? Wow, okay, very good. I might have some questions for you. Flix, anyone use Flix? Wow, and Strand, but nobody's used. You use Strand? What the fuck?
I read the manual because I implement a similar language, but Strand doesn't have a backtrace. So
no, it hasn't. We're going to talk about this. Very good. So the way this talk is going to work, I'm just going to call people on stage that have used the language, and then you can explain how it works. No, but I also have used all of these, but not in production or anything, right? And I haven't developed any of these. I'm not an active committer of any of these. So the level I'm going to talk about it is I'm going to tell you what fascinates me about it. I'm going to pick out something that I think is super interesting about the language. Flix, of course, has many other features other than the effect system. But let's talk about the effect system, because that's like super. One more small note. It's also, I try to cover a variety of sort of origins of languages, right? So Flix is an academic language, mainly University of Aarhus. Unison is its own company, but it's like a non-profit company, company for public good or something it's called, or public benefit corporation. Strand is a historic language, from the late 80s, early 90s or so. I think it hasn't really made it. And Verse is commercial, right? Epic Games. If you haven't heard about Verse, we're going to talk about this in a second, obviously. Flix. What if the effect system, what if we could use the effect system to actually optimize evaluation, right? So from Aarhus University, it's not one person, of course, but I think he's kind of the professor who leads the team. Also open source, other people can contribute. It runs on the JVM, so you can use the whole Java ecosystem. And of course, yeah, it's relatively young, maybe 10 years old now, if even, maybe even less. So of course, a lot of functional languages existed when they started, like OCaml, Scala, and so on. Effect systems, or effects, right? This is something I don't know what you program with, but the mainstream languages we use usually don't have an effect system, right? They have type systems, but most languages kind of ignore this. What are we talking about? We're talking about I/O, for example, exceptions, changing state, right? You know, side effects when you have pure functions that only evaluate to a result and that are referentially transparent and that, that are pure, obviously, that have no side effects. But in Java, in Go, in JavaScript, whatever people use, we just don't know, right? If we look at a function, you don't know if it has any effects or not, right? It doesn't have to be declared. Haskell is an exception, right? Haskell is basically pure, and they use monads. No, what do I do? So that's already big progress, right? Here, if I want to have side effects, I can express this in the type system, right? I use certain types that are of a certain class to express that I'm going to do I/O, that I'm going to have a side effect. But monads are, yeah, they don't, if you have many effects, or if you want to combine different effects, right, it gets a bit tricky, right? You cannot just say, oh, this is I/O and maybe and config also, right? Then you cannot just flat map on that, then you have to have a transformer, and it can get a bit cumbersome. And also, there are certain things we're going to see with an algebraic effect system as Flixes that I think you cannot do with monads. So in Flix, effects are properties like types, right? They are an extension of the type system. So you say I have a method, a function called greet in this case. This one doesn't return anything, and it has an I/O effect, right? Because it prints to the console. This is a pure function. This is the default. If you don't have any effect annotation, it assumes it's pure. And you can have multiple effects, right? And you can see maybe from this notation, it basically treats this as a set, right? You can have a set of effects, right? So, well, this one, okay, is parse or something. You can have some sort of parse exception, and it prints, so we have the well-known I/O exception. This means, if you have questions at any time, as I said, right? So, considering these as a set, we can also work with this a bit like, well, what's the next slide? Is it about the set operations? Oh, it's about effect polymorphism. Oh, this is great. Actually, in an old version of Flix, the map operation was defined as pure, so you could only put pure functions in. But now they've introduced effect polymorphism, right? So if you have higher order functions, what's the effect of this, right? It's the effect of the function you put in, right? So you can have map with some generic order. Yeah, it's like generics, right? Or a polymorphic effect. You can say whatever the effect is, or the set of effects, right? Whatever the effects are of the functions I put in, this is going to be the effects of my map function, right? So this is, of course, a very substantial usage of effects to this declarative use, right? So I see what effects I have, and I can also use this to constrain things. For example, because it considers the effects a set of effects, I can say, okay, I want the effects to be complementary, basically, to this, right? You can say, okay, oh, this is a bit low. I hope people can read this. So what this is here, the idea is I have a function that can throw, that has a throw effect, right? That can abnormally terminate. I can throw an exception. And I want to handle this somehow. Now, if I handle it, the worst thing, or something I don't want, is just throw another exception, right? So I say, the handler function I put in can have any effect, I don't care, but not the throw effect, right? I think this is, for example, something I cannot express with monads, right? I cannot say, okay, this is like something that's not I/O or something, right? And then whatever the effects are, minus throw are the effects of the handler function, right? To me, this is mind-blowing. Like, I can constrain a function and say, okay, this can have any effect, but not this effect. This is, yeah, this is very expressive, right? This is something we cannot express in other languages. And I think this is really unique to Flix because even other effect system languages like Kuka or Coca or F, they don't have this kind of set-based system. And this is, again, this blows me away completely. I said in an older version, the map function only took pure functions, right? And the reason, or one of the reasons they gave was they said, oh yeah, because we're going to evaluate this lazily, right? Map is lazy, so we only want pure functions, right? So lazy, you might have heard about lazy versus eager evaluation, right? Eager evaluation will just kind of sequentially evaluate everything. Lazy evaluation will evaluate on demand, right? If I put something in, if I have a function that takes x as a parameter, but x is defined as a result of an expression earlier, then this, this expression will only be evaluated at the moment I kind of pull x, right? At the moment I use it, if I'm lazy. This is fine for pure functions, right? Because it doesn't matter, like pure functions are will just evaluate to the result, nothing else is going to happen. It doesn't matter when I do it. And once I've done it, I can just keep using the value, it's not going to change. With side effects, if you change the state, if you, there usually you don't want lazy evaluation because you get this kind of non-deterministic output maybe. Let's say you have a function that, yeah, well, that outputs something, it prints something. And then you look at the code and you think at this point where it's evaluated, it's going to be printed, but then it's only going to be printed much, much later. It looks out of order. Or if you have, let's say, well, this just counts, right? This is an obvious function that works. But this is not about laziness, this is about parallelism. But just imagine you map something, we talked about the map function, and this changes the state of something. Well, this is about parallelism as well. Like, pure functions, well, if you just count something, if something's pure, it's probably safe to execute it in parallel as well, right? While if it's impure, the effect might depend on the execution order, right? If you think about the effect might be moving a cursor around, right? If I go left and then right will be different from right and then left, right? So the, yeah?
This should be a compile time choice, or can we use the type system to make this a compile time choice, what you have on the slide?
Yeah, at what point, well this is, I think, well it's called purity reflection, right? So you can use this in your own code. And then the compiler, yeah, I guess the compiler will sort of use the right function. I guess you could use it at runtime as well, yeah?
Well, is purity, is it not expressed in the type of f?
But it's a polymorphic function, right? You don't know if it's if the function that is passed in has effects or not, right? So this is the count function takes a filter. Well, it will count the predicate. It will count the elements that match a certain predicate, right? And the predicate function. This is not real code, right? This is just to demonstrate it. In this case, our predicate function here will say yes or no. It's please count it, but it might also have effects, right? So at this time, if you build a library with this count function, you don't know what kind of function is going to be passed in, if it's going to have side effects or not. But you can still you can say, okay, I'm going to use a parallel count when it's a pure function that is passed in. Yeah.
Question: if effects are declared, the compiler knows about effects. Does this mean that the compiler can detect errors in relation to effects at compile time, not at runtime, and in this way help me to write safer code?
So I'm just going to repeat the questions, because first I should have asked, has your question been answered? Is that, or? No. No, okay.
Is purity visible by the effect annotation of the type?
Yes, if it has no effect, it's pure. Exactly.
But then? Oh, okay, answer his question.
So the question was if the compiler can detect errors related to side effects and then help you. Well, I'm not sure if I understood the question, but it can detect if they don't match, right? If you have, if you expect a pure function and you put in something that's not pure, that's not going to work. That's going to be a compile time error, right? So the compiler knows about effects, yeah.
Okay.
So that's the basic idea of effects, right? That you say, okay, I can ensure at compile time Just like I said, right? Like I do not allow a throw effect for this, or I only accept pure functions for this, right? Or I expect certain effects. So it expresses the effects that the code has. Yeah, another question here.
Yeah, so does this code mean like at runtime you can check if this function f that is effectful actually is pure or not? Is what it means?
Now that you say it, do I know if it checks it as, how would I be able to tell if it checks at compile time or at runtime? Well, at compile time of this function, yeah, no, it's at runtime, right? Because this has been compiled. This is part of a library. Also, yeah, this is probably why it's called reflection. Yeah, it will check at or at linkage time or whatever. Like I don't know what. It doesn't really make sense to do it at runtime, right? So I think it is at compile time, but I'm not 100% sure. One more, okay?
Just maybe to maybe answer the question, it looks to me that this is at compile time, so
Yeah.
is variable. So the code was executed at runtime. However, if the compiler is sufficiently smart, for instance, if you have a specific argument for EF, then the inliner might be able to choose one of the branches.
Yeah. That's a very good answer. So again, I haven't implemented Flix as such, right? And this is, I'm just playing around with this. And I love this idea, though, right? Of saying, OK, I can optimize at compile time or runtime, be it as it may, based on the purity or non-purity of the function. Like, where can I do this? In what language? Right? And also the idea that different evaluation strategies apply, whether I have a pure function or I'm going to get to you. It's a bit like, well, no, not going to diverge. OK, one more question, but then we're going to move on.
Are there more values than pure and impure to purity?
Yes. Haven't we even seen? Well, pure means there's no effect, right?
I know,
So,
but
yeah.
is there more than pure or impure?
Yes. We have, it's an algebraic effect system. You can write your own even. So the built-in effects are, I think one is random, that one is console, one is I/O.
I mean, you basically distinguish between purity.
You want to check for specific effects, for the purity check.
Yeah.
Is this a complete case distinction?
Yeah, I think it is. Oh, that's a good question. As far as I know, there's no checking at runtime for like any effect. Ooh. But wow, why would you want to do this? You want to evaluate
Is there something like maybe pure or?
maybe pure, like different levels of pure. But this pure is a very clear concept, right? You can say it has no effects. But this is an effect system where you can build your own effects and so on. Obviously, it's having checks for you. If you want to check for arbitrary effects, I don't know if there's some reflection for this. You probably have to build it yourself because you also build the effects yourself, right? Wow, I love how engaged you are. So let's focus on pure versus impure for the runtime purity or the compile time purity detection. But there's more, right? The idea of algebraic effects is that effects are basically things you define, and you define operators on it. And, well, operators. You define something to raise the effect, right? Basically to throw, to invoke the effect, and you can build something to handle it. So let's just very quickly, so this also is an experiment. So, OK, I think it's also the last slide on effects. This is one. So one thing you can do with algebraic effects when you can build your own effect. Can you read this? Is this big enough? This is an effect, right? I say I want a specific effect for division by 0, right? Like I don't know if there's an exception in JVM languages for this, but so this is one use case of algebraic effects, right? You can kind of build your exceptions, but it's different from exceptions. We're going to see this on the next example. But the basic idea is this could be, well, throw is a keyword in Flix, so you can't call it throw. But calling this method, well, this is just an interface, right? But then you can call this method, and this raises the effect, right? So this, if y is 0, this effect will actually happen, so to say, right? There will be a freeze, right? It will be a continuation will be saved, and it will go to the place where the effect is handled. As I said, a bit like an exception. And in this case, the handler will just says, oh, it was a division by 0, right? So basically, we built our own division by 0 exception here and caught the exception here. But effects there's a fundamental difference between exceptions, if you know exceptions from Java. The idea of an exception is that the execution aborts and you go up the stack trace until the exception is handled. With effects, it's different. Where's the... okay, because I clicked the link, it didn't open a new window. It just... we can see it like this. With an effect, you can resume, right? It doesn't abort the execution and kind of pop up the stack trace. It freezes. It saves a continuation, as people probably would say. It saves this continuation, and then you can, in your handler, you can go back and resume. So here, no, this is the same example. Okay, now I'm never going to find the link. So now we're going to do some live coding together. Let's say we say the diff by 0 takes an int, and probably does it also need to return an int? And then if we call it, we pass the value of x here, and we change our handler to say, instead of just printing something, we zoom with x divided by 1. Oh, no. Okay. So now, but the point is not that it makes sense to say, oh, you could, because, hey, divide by 0, that's probably not what he meant. I'm just going to return the original value, right? Actually, now that I'm saying this, instead of x divided by 1, I could just have said x, right? But the fun thing is, it didn't abort the execution, right? It went back to where I reached the effect, and I can resume the computation from here. So that makes it very universal. You can use this also for async processing and so on, right? For things to basically to snooze and then be woken up and so on, right? So it's a very powerful system. So for me, it's I don't even know all the things you can do with it yet. I think it's amazing. So Flix has other nice properties, but my basic point was I love the effect system. I think effect systems, well, you can see effect systems, well, we're going to talk about Unison. I'm not going to talk about abilities in Unison because I want to focus on a different topic, but it's very similar to Coca, I think. It's not this set-based approach, but you basically have the algebraic effects as well. You don't have this minus and complement thing. Oh yeah, I talked about the set-based approach. So you can have this complement minus throw. You can, of course, also then remove effects, right? You can say, okay, I'm going to take this effect. I'm going to have if I have a method that has two effects, like a console and I/O, or random and I/O, I can have a handler that kind of captures one, and then I only return, no, I don't return, but then I only maintain one effect, right? So you can really, it's really a set in Flix where you can add things, you can remove things, you can have complements of things. You can have an intersection, right? If you have two methods that take different effects, one takes I/O and random, one takes I/O and state, then you can only pass in something that has only the I/O effect, so you can use it with both. Yeah? Yeah, I really would have to think about this. This is something I cannot answer right now. My quick answer would be I don't think, in terms of the effects, it has an effect. But in terms of the, yeah, I would have to think about what it means for the outcome of the program. But the claim is that order doesn't matter, at least on the declarative level, right? You can, it doesn't change the semantics of your program. Oh, it shouldn't change the semantics of your program in which order you declare the effects. I think that's also true for row-based effect systems. They're very, very, very similar. And OCaml, I think, also has a similar one. Scala, the new Scala abilities, I haven't worked with, but as I said, there's another talk. But OCaml is already somewhat mainstream, right? And Scala, I think, well, definitely more than Unison or Flix. So I think effect systems, as I said, are going to be a big thing in the future, and they're just super useful. So we're going to get them in more languages, so it might make sense to look into them. Let's move on, though. Oh, okay, just to give it the proper respect, there is more, of course, in Flix than the effect system. Region-based local mutation, awesome. If you have, you do in-place mutation, is this effectful or pure? Right, it's effectful, right? At least if you can pass, or you would have to limit it to a certain scope, right? If you have some array and you mutate it and pass the reference or return the reference, right? This is considered a state effect or a mutation effect. And the problem with this is, if you say, okay, this is changing things in memory that can be referenced from somewhere else, at least in theory, referenced from somewhere else, is stateful and is an effect, then that is quite restrictive, right? This kind of pollutes your code base, or it goes, they say it goes viral in your code base. Let's say you want to optimize something. You want to, I have an example for this, if the link works. Here, we want to order a list by copying it into an array and use quicksort on the array, because we assume it's faster than a linked list, right? But if this would be impure, then all my code that sorts a list somewhere would now be impure, and I would have this naughty effect that I have to pass around or handle somewhere. But so any mutable arrays in Flix and other mutable data structures require a region. So there's a static region if I don't care if it's supposed to be a global array, but then I have an I/O effect. But here, the effect is contained within the region, right? It limits the scope, limits the visibility and the referenceability. It's like borrowing, right? I say, okay, I'm going to mutate some stuff here, but I'm going to restrict it to this region, so I can stay pure, and I don't pollute my code base with effects that I don't really want to handle. Right? This is, yeah.
What did this talk with concurrent calls?
I don't know. This is you mean if the region also locks the, if it's also like a mutex? I don't know. That's a good question. But here the region is kind of, well, it depends. Well, it's on the JVM, so it's probably reserved on the heap. But it's local to this method anyway, right? So in concurrent code, it would be two different arrays. If you have, if the question is, if you call this method multiple times and it works, it would work on different arrays, right? Because it's allocated in the as a local variable, if you will. Yeah. Okay. Wow. Okay. So we will spend less time on other languages. But Flix is crazy. Okay. Hey. If you think effect systems, regions, who cares? But I want logic programming. Here you go. It has data log built in, right? So it's a bit like Prolog, but not quite complete. And you can define predicates. We say, okay, Zeus is the father of Kronos. Apollo is the father of Zeus. So the children of Zeus are Apollo and Ares, and the ancestors of Apollo are Kronos. I don't even know if this is correct. But if it's incorrect, it's because the data is incorrect and not the program. So it has data log built in. Flix is crazy. It's an awesome language. I don't know. Well, I wish they wouldn't use the JVM though. They have type classes. If you know them maybe from Scala or Haskell. Here they are called traits, high kind of types, type inference. They have CSP style concurrency with coroutines and channels. Moving on, next language. Unison. Unison, developed by Runa and Paul. They are famous for writing the book Functional Programming in Scala, and I think they also made a Kotlin version of the book. And I think they've been working for this for 8-9 years now. It's a statically typed, purely functional language. It has, in terms of type system, it's also very powerful, but it's also, the language has more than the things I want to show or I want to talk about. But the big idea, and this is not just me saying it, the big idea that kind of drove them to do this language, and that has huge implications and changed the whole way we think about programming is content addressable code. And well, Unison was the one thing where like a lot of hands went up, right? So please correct me if I tell stupid stuff here. We're going to look at this in a second, but the idea is, well, maybe we're going to look at it first, and then just keep these ideas in mind, right? What does it actually mean if you store? How do we work? We have file systems, right? And I write a file, and this is kind of the way I address my code. Or maybe I compile a library, and then I have a name for the library and a path or a qualified identifier, and this is how I identify the code. And then this tells me nothing, right? This is just a label. It tells me nothing about the syntactic structure of the code and if it's what has been done with it, how it has been tested and everything. But if I say, okay, I'm going to compile the code, I'm going to look at the syntax tree. I'm going to take the syntax tree and create a hash code out of this. What? No, I have you say on the 40-minute thing. Then this means I have kind of immutable units of code that I can just use from anywhere, right? So, okay, I need to be much quicker here.
I guess we can skip the question.
Yeah, no more questions. Exactly. Questions at the end. What? Oh, problems. Where's, what? There's another. That's, how can I stop this one? No. So, the way you manage your code is with the Unison Code Manager. And let's say I have a square function. Couldn't resolve any of these names? Maybe I don't have natural in scope. Create, what was it? Create project create? Project create bobconf. What was the syntax there? Who knows? The Unison people. How do I create a new project? I don't know how to create help. Help! Clone. Okay, this doesn't have it all. Wait, but it says when I start the project.create, of course. Okay, now the unit I work in is the project, right? But of course there's like a global library or there's like a standard library, but this is pulled into my project now. And now it should know, it hopefully knows not now. Where's my Scratch file? Do I have to do anything here? Okay. Okay, this will, sooner or later this will appear here. So now I define the square function, but it doesn't care that it's called square, right? It's identified by a much longer hash code than this. This is just a readable kind of subset of it, right? It's like 512 bits. So now it's stored in my code base with this function. What if I define another square function with a different name? So I take square true. Oops. Yeah, just ask the question while I type. What's the question?
What happens on collision?
Sorry, what happened to what?
What happens on collision?
Hash collision. I don't know. The world ends.
So choose your algorithm for hashing wisely.
Why is it scribbly now? I got confused here. Oh, interesting. Okay. There's some weird.
Is there in 10? Does it need to have the right indentation there in 10?
Line 10.
Line 10?
Line 10? But it's still scribbly. Oh, of course, live coding. Stupid error. No, it got confused here. It worked earlier.
You didn't say thank you.
Okay, what would happen is that it would have the same hash code. I don't know why it's not working right now. But it is weird with also how it displays it. What is it? Why are these indented? This is just to this is really just to piss off presenters. So you see square true. Oh, please have the same hash code. Yeah, and one other name, right? Because it doesn't care about the name, right? It takes the syntax tree and now, well, now I could do loads of things. Of course, if I would post this to a global code base, anyone who references this would reference it by the hash code, right? So, and this will never go away. Now I define something else. I define a new version of square, and I will calculate it. Oh, yeah, okay. Also, always write tests. Oh, I hope. Nothing else right now. Why is there? Okay, this is a watch expression. It should test it. Never mind. Okay, now I have to define sum as well. There's some other weird annotation thing going on. Square that's some. Where's the? Oh, the test passed. That's nice. But also, I have to get rid of the square now because what's wrong with sum now? Who knows? Does anyone see what the problem is?
One space too much?
I got confused here. I was surprised. One of these instead. And sum. But I have to. Right, so is it really just the white space? No, there's some. I don't have a great idea right now, but the if it worked as it should, I would now have a different definition of square, but with the new hash code, right? Now, in my local code base, it will offer me to replace all the instances of square because it basically stores a bidirectional link, right? So, but also if I had published it externally, people would not be affected by the change because even if it has the same name and I would publish it in the same namespace, they would link to the hash code and not the name of the file, right? So this is really something you need to kind of. Also, now I lost the presentation completely. It's kind of weird to get the head around to that, like what it all means. Because this means also that you can sort of, if you have access to your project, right? If you deploy it somewhere where it's accessible, you can just deploy a function somewhere that uses all sorts of other functions and just pulls them from the repo with the hash code. 5 minutes to go, cool. And this actually works, right? There's Unison Cloud. You can deploy functions on Unison Cloud that use anything. Also, in terms of compilation and test, right? If you have it in your local code base, it's been compiled, and it's kind of, it doesn't change, right? It's not referenced by name. It's the actual syntax tree of the file. So it's never going to be recompiled. So compilation is like super quick because it just uses all the already compiled functions it has. So yeah. It's weird. It's kind of a bit of a kind of closed world thing. It's kind of hard to imagine. It's very different, right? It's very different from how we usually work. So, but it's also amazing, and I like it because it is really a big idea, right? It's really a challenging, a very basic fundamental assumption that we have. We use text files to work on our code, and we reference them by names. So. This is, I think this is super powerful. They have an effect system, they have Unison Cloud. Also then, if you want to do diffs, they can do this on the syntax tree, so they don't compare texts. I haven't had a merge conflict because I've only been using it by myself. So, Strand. Yeah, sorry, Unison, but so bad timing here, I'm sorry, but I think, well, for me it's important to kind of make you curious, right? I'm not going to explain Unison and how it works, but I want to make you curious and say, hey, there's something to discover there, like this content addressable code. I can be very quick here because there's not so much to discover here, because this is very historic. I had to implement an interpreter for this at university, and this is how I fell in love with this language. But the idea is, it looks like Prolog. Right? Has anyone seen Prolog? I guess you have. And in Prolog, this would be logical expressions, right? It would be this would be true if this is true and this is true. Now imagine it means something different. Imagine it means this process terminates when this process terminates and this process terminates. And there you have parallel execution. And now by default, everything is parallel. And in Strand, you just write your programs like this. And then it basically does a term replacement, right? They say, okay, to do this, I can replace this with this and this, but I need to figure out what R1 is. Well, okay, in this case, it was passed in. But here, it will say, I will do this in parallel. I compute A, I call compute B, but compute B needs X. So in this case, it will just suspend this and wait until X is resolved, right? It has a single assignment principle, so you can only assign to X once in your program. Once X is resolved, this will be kind of unsnoozed and can be computed. So this is how you can enforce sequential programming. And I find this, well, we live in a world of multi-core processors and parallel. We have parallelism available all the time, but still our languages are sequential, and we have to do extra work to do things in parallel, right? You have to start coroutines or actors or threads. And it's always on top of the regular language, right? It's something added on. And here they just revert it. They say, no, the default is parallel. Just write down what needs to be achieved. We're going to do everything in parallel unless we need to resolve data first. So it's called data flow parallelism, I think. It's a bit tough to play with it because there's really just one implementation on GitHub that uses it's implemented in Forth. So you have to compile the fourth VM first or so. It doesn't run on Apple Silicon. But if somebody is looking for a great idea for an open source project, build a Strand interpreter, or build a Strand compiler. It did have a bit of influence on Erlang and other systems. But I love the idea of taking the Prolog syntax and just saying, hey, we use completely different semantics. We just make everything parallel. And now the craziest language, verse. This is like, there isn't even one big idea. This is like the idea of BobConf, best of breed, right? Like, let's do all the great stuff. Let's do all the weird stuff in 1 minute. So one big idea in verse is control flow. There's no ifs and checks don't resolve to Booleans, but they can fail. But failure is not that bad. Failure is kind of integrated in the control flow. And if you, for example, okay, I'm just going to keep this very quick. You need a failure context. It also has effects. It's different. It's not an effect system where you can define your own handlers, but it has predefined effects. If you use the failures, or if you don't, if you create failures outside of a failure context, you need the decides effect. And transacts is something like, defines something like software transactional memory, right? It says, okay, all this is going to be atomic. You do this, then this, if this fails, this is going to be reversed automatically. Right? Now you have kind of rollbacks automatically integrated into the language. Wait, how does this work if I have an I/O something? Yeah, if you have things that cannot be rolled back, they have a no rollback effect, right? Like if you call, okay, give me 1 minute just to wrap it up. So absolutely crazy. So it has a completely different idea of control flow in the program. Lenient evaluation, not lazy, not strict. It's kind of the compiler decides when things are evaluated. Types are functions. For is exploring a solution space, right? This is, if you did the last advent of code, right? This was kind of counting neighbors, like in Minesweeper. You look for the tiles in a two-dimensional array that have numbers and you add them up. And here, if you get out of bounds, this will just fail, but the for loop will continue, right? It's kind of, it's not a loop over elements and then it blows up if you have an index out of bounds exceptions. It says, okay, this is outside of the solution space, I'm just going to continue. Just going to continue is the word.
wrap it up now, otherwise.
The thing is, if you want to try verse, the only way to try verse is to install the Fortnite SDK. It's free, everybody can use it, but it's part of the Unreal Engine, scripting engine, and the Fortnite thing. Good. What we learned, effect systems, content investable code, logic, parallel logic programming, and verse, crazy language. Simon Peyton-Jones, the Haskell guy, the F# guy, has developed it, and it's part of the Unreal Engine of all places. Thank you very much.